So, it's right here. Hi, second period. Say hi. That's everybody saying hi. And all my previous math classes who also watch my videos because I know you guys love me. Some of my other calculus students like watch the videos I upload from my current calculus classes and then they comment on them. I'm like, you guys don't have to do that. Yeah, that's right. I got a lot of views because of that. All right. So, the first thing I want to teach you guys how to do is I want to teach you how to reset the memory on your calculator. Here's why. Some of you guys have calculators from the school and you've used them and people from last year messed up some of the settings on them or maybe altered some of the settings on them. I want to make sure it doesn't mess you up, so I want you to reset your memory. In addition to that, some of you guys are in other classes that you will use this calculator for, like chemistry or maybe physics. If you change some of the settings on the calculator, it could mess you up for this class. For example, physics uses degrees a lot. We never use degrees in calculus. So if you change the mode on your calculator to degrees and you forget to change it back to radians in this class, it'll mess up all of your answers. And I have had students do that on tests before and they get all the questions wrong because their answers are, I let them go back and retake it, but all of their questions, or all their answers were wrong because they left their calculator in degree mode instead of radian mode. So, my suggestion is reset your calculator's memory as often as you remember to, and that way it just kind of goes back to its factory reset settings. If it's ever messing you up or like not working properly, try to reset it and see if it works again, and sometimes that's all it needs. So, here's how you do it. Are you ready? Hopefully it's on. Everybody has on. You're going to go to this button right here that says second, this blue button. Push second. And you should see a little blinking arrow now. Then down here where it's the plus button, underneath plus in blue it says MEM. That stands for memory. So push plus for memory. You're going to go down to reset, which is option 7. You can either scroll down with the little cursor and then push enter, or if you just push the number 7 on your calculator, it will also reset the memory. All right, you have some options. If you want to reset just the RAM, if you want to do the archive, if you want to do all. So we're going to scroll over to all. So with the right-hand arrow, scroll over 2 times until you get to all, and push 1 or push enter to reset all of the memory. And then it'll say, do you want to reset it? Are you sure? And you go down to option 2. Yes, I want to reset it. Option 2. Do you have things right now? Yes, please. Well, do you have stuff on there that you need? Reset the settings maybe. If it's your personal calculator, don't worry about it. Oh, okay. Yes, some of you guys have your own personal calculators, and you can download apps on your own personal calculators. And so if you're worried about it redoing that, you don't want to re-upload them, that's fine. I'm just talking about the people that have school calculators. All right, it should say memory cleared when you're done. Sound good? Yes. Okay, let's use them. Look at example number 1 for me. Example number 1, and it's on your paper, remember? So those of you guys who are watching this video, this is the example on the paper I gave you in class today. So if you haven't gotten that out yet, please get that out now. All right, so example number 1 says, what is the limit as x approaches 2 of the function x minus 2 over x squared minus 4? And then it says to evaluate the limit graphically and tabularly. So on our calculators, I'm going to teach you how to put this function into your calculator. So you can clear this, and then I want you to go up here where it says y equals. So push y equals, and these are the places for you guys to put all of your functions into. So we're going to put in the function x minus 2 over x squared minus 4. Now, before you do that, don't put it in yet. I want to teach you how to put it in the proper way. I know for a fact that some of you guys, well, hold on, let me put it up here. You're going to want to do this, or this is at least the way you probably know how to do it. You would put it in as y equals, and you put x minus 2. You can't see that. Let's put it in red. Maybe you'll be able to see red. You would put it in as x minus 2, and then you have to put parentheses around it, and then divided by x squared minus 4, like that. Can you guys read that? Yeah. Okay. If you do not put those parentheses, it will graph the wrong function. Every single time you have to group the top, you have to group the numerator, and you have to group the denominator, or it will graph the wrong function. I bet if I let you guys continue to do it this way, some of you guys would forget the parentheses and you would graph the wrong function anyway, because it's just human nature. You would forget to put them in and it wouldn't work properly. So I'm going to teach you how to enter it in as an actual fraction so that you can physically see with your eyes to make sure that it looks like a numerator and a denominator, and that way you can make sure you don't mess it up. All right? Perfect. So here's what we're going to do. Before you enter in the function, I want you to push right here where it says, where is it? Oh my gosh, it's been a long time since I've done this. Let's see. I think it's the green button. Push the green button. And then push the y equals button again. See how for green it's F1? Push that. Alright, and then the very first one, it says N/D. That stands for numerator/denominator. Do you guys see that? Yes. So it's the green alpha button and then the y equals button, numerator/denominator. And then it pulls it up, and now do you guys see how it's a little blinking box for a numerator and a little blinking box for a denominator? Yes. Now when you put it in, it will be a fraction, so that you do not have to do it on your own. So, in the top, push x minus 2. Do you guys see where the x button is?
Yeah.
My finger's pointing to it up here on the screen if you don't see x. It says x t theta n. Minus 2. To get to the bottom, you just push the down arrow. And then we go x squared. So again, push x. You can either push this squared button or there's a caret button. I'm pointing to both of them. You can push x squared, or there's a little up caret, and you can do that and then do an exponent of 2 as well. I'm just going to push x squared though, since it's here for us. And then minus 4. X squared minus 2 over x squared minus 4. Yes?
When you put alpha and then y equals, it just erases, nothing happens.
You might need to reset it.
Do it. Because I had it on an option where it had like equals like greater than less than on the bottom, so I don't know.
That's why I always tell students to reset it, because I don't know how to do it when it's not. I don't know how to undo what you did. No. You guys, there was a great question. The question was, do you have to put parentheses if you're going to do it like this? And the answer is no, you do not need parentheses. If you're going to put it in this fractional form, the calculator understands that it's a fraction here. All right, here's how you graph it. Well, actually, let me teach you the table first. So do me a favor and push, do you guys see right here where it says in blue? Do you guys see right here where it says blue in table?
Yeah.
How do I access the blue features again? Second. So push second table. Now here's the problem with this. Do you see how they put in their own values? Or when I say they, I mean like the calculator minions. The calculator minions put in their own values?
Yeah.
But are you able to type your own? See if you can type a number in.
You can scroll down.
Can you type your own numbers in? Okay, great. So I don't want the numbers that the calculator people told me to put. I want to put my own numbers in there. Because essentially I'm trying to evaluate the limit as we approach 2. And to find the limit as we approach 2, we need to plug in numbers that are really, 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 really close to 2 from the left and really, 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 really close to 2 from the right. So for example, like 2.0000001. So obviously I can't use their whole numbers. That's not close enough to 2. So here's how you're going to get the calculator to let you type in values. Are you ready?
Yes.
Perfect. Me too. All right, you ready? It goes blue for second. Push second. And then underneath window, right here, I'm pointing to it on my screen. Underneath window, it says table set, TBLSET, table set. These two down at the bottom, it wants to know, do you want your independent variable to be an auto, meaning they'll fill it in for you, or do you want your independent variable to be an ask, where it asks you what you want to put in? So scroll down to that one, and scroll over to ask. I want it to ask me what it's going to put in. Don't tell me what you want to put in. Leave the dependent... Leave the dependent setting on auto. If you put the dependent setting to ask, then you also have to type in y values. I don't want to type in y values. I just want to have to type in the x values and have it tell me what the y values are that correspond to those x values. So leave that one at auto. When you're done with that, when you set your independent variable to ask, go back to the table again. So we go to second table to go back to the table, and now it's blank. And now you get to type in your own x values. So remember that we are typing in numbers that are very, 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 very close to 2. Can you tell me a number that's very close to 2?
2.0001.
2.001. Let's try that. Everybody type that in. 2.001. Push enter. Can you give me a number that's closer to 2 than that?
0.01.
Closer to 2 from the same side. This is from the right-hand side. Give me a number that's still from the right-hand side.
2.000.
2.00001. How about 2.00001? 2.0000001.
It became 2.
I know.
It says error.
What did it say error for when you typed it in?
I typed in like 100.
Yeah, so you might realize that your calculator only reads a certain number of decimal places. So notice on mine, I typed in 2.000000001, but it put 2 because it's going to just tell you what the limit is. So look at these numbers though before I went super far. It was 0.24994, 0.24999, and then it just went to 0.25. So that means the limit from the right-hand side is 0.25, which is 1/4. Right? 1/4. We okay with that?
Yes.
All right, perfect. What about the limit from the left-hand side? So what's the number that's coming in from the left, a number less than 2? How about 1.999? 1.999. 1.999999. And then it also, no matter how many 9s you type in, it's still going to go to 2 as well. So mine says 1.999 was 0.25006. Then it went to 0.25. So here's why I want us to look at this in a table form. If you look at the limit from the left, that was these first 4 that I typed in. The limit from the left, as you get closer and closer and closer to 2 from the left, it was going to 0.25. Then the limit from the right, as I got closer and closer and closer to 2 from the right, it was also going to 0.25. So the left-hand limit is 0.25, the right-hand limit is 0.25. Because they're equal, what do I know about the limit as we approach 2? It equals 0.25. It exists and it equals 0.25. Perfect, which is 1/4. All right, so tables. That's how you read a table to figure out a limit. Go towards the number from the left, go towards the number from the right. If they're both going to the same number, then the limit exists and the limit is equal to that number. So far, so good?
Yep.
Okay, now I want to look at the graph.
Graph.
Push graph, which is not one of the second features. Just push this white one right here that says graph. This one right here.
It looks so cool.
All right. Now, this is a rational function. This is a rational function. You can tell there's a vertical asymptote at -2, and you can tell there's a horizontal asymptote at 0. You may even know just by looking at the function that there's a hole. You know there's a hole in the graph, right? There's a hole in the graph at 2. Because if you factored out the bottom and top, you would realize that x minus 2 is a factor in both the top and bottom, so there's a hole at 2. Do you guys see a hole on your calculators?
No.
No. Even if you zoom, eventually you might be able to see a hole. Eventually your calculator might be able to do that. Here's the problem with calculators. Everybody look up here for me. Calculators are pixelated, right? They come from pixels, which means that depending on how you're looking at it, it might not appear as an actual hole in the graph because there's just too much information and it doesn't know to like spit that out at you. So unless you knew there was a hole there, you would never know just by looking at it. But I want you guys to make sure that you're using your algebraic knowledge to realize, oh wait, hold on, that doesn't seem right to me. I think there's a hole in the graph. So here's how you could figure that out. Do me a favor. Do you guys see this button right here that says trace? Push trace. Type in 2 and push enter. So push trace, then type in 2 and push enter. What does it say? Y equals? Blank. That's because there's a hole in the graph. It's undefined at 2. There is no value for y at x equals 2. Now try to type in a number that's really close to 2, like 1.99999. And notice that it says y equals 0.25000625. And if you typed in a number that was even closer, it would go closer. If you typed in a number that was closer, it would go closer. It shows you a little blinking star right here on the graph. Do you guys see that blinking star? All right, that's where the function is. At 2, it goes to 0.25. So, graphically, it goes to 1/4. Tabularly, it goes to 1/4. Tomorrow, maybe Monday, depending on how far we get. No, that's true. Monday, we're going to look at how to figure it out algebraically. So without a graphing calculator, how could we have figured out that the limit was 0.25? Most of you guys, by the way, already know this because you were in Mr. Jensen's class, and you know that all you have to do is get rid of the hole and then plug the number back in, right? So if you did that, you would get 1/4, but we'll still look at it again on Monday. So you guys are just one step ahead. So do me a favor. On your paper right here, for example number 1, can you put the limit equals 1/4? And then I don't need you to necessarily write much else because that was more of just a graphing calculator exploration.
This is like honestly.
Okay, Let's move on. Let's look at example number 2. Example 2 says the function g is defined over the real numbers. This table gives select values of g. What is the reasonable estimate for the limit of g of x as x approaches 5? So do me a favor and look up at my screen real quick. I'm going to go towards 5 from the left. So here's these numbers. 4, 4.9, 4.99, 4.9999999. So from the left, I'm looking at these. Let's look at the y values. 3.37, 3.5, 3.66, 3.68. Cool. So far, so good? Could you give me a reasonable estimate for what the left-hand limit would be going toward?
4.
Maybe 4. It doesn't look like it's growing that fast, though, right? 3.37, 3.5, 3.66, 3.68. Maybe just 3.68. You okay with that? All right, I want you guys to write that down into your notes. The limit as x approaches 5 from the left, because these are numbers smaller than 5, of g of x, and then let's write is equal to 3.68. And again, I'm reading those down, so as I go toward 5, it looks like the limit is going toward 3.68. Now how about from the other side? From the other side, numbers greater than 5 would be these ones, and I'm reading it up. Let's look at it as we read it up. So here's numbers getting closer to 5 from the right-hand side. We have 6, 5.1, 5.01, 5.001, and here are numbers. 3.97, 3.84, 3.7, 3.68. What would you guys say is a reasonable estimate of the limit as we approach from the right? 3.68. So the limit as we approach 5 from the right of this function is equal to 3.68. Are my left and right hand limits equal to each other? Yes. Then a reasonable estimate for the limit of g of x as x approaches 5 is what? 3.68. Now, is that what the actual function is equal to? What is the function actually equal to at 5? 6.37. It does not matter that the function is equal to something else. This might look like a hole in the graph with a point somewhere else, right? Where the hole is at 3.68, but the actual point on the graph where the function is equal to would be at 6.37. So again, when you're looking at tables, look around the point, not at the point. Same thing with the graphs. Don't look at the point, look around the point. So far, so good? Okay, let's go on to example 3. I want you guys to try this one. So think about this for a minute. Talk in your table groups about what you would choose, A, B, C, or D, about what a reasonable conclusion is based on this limit. If you're watching the video, you can pause the video. So let's look at the limit from the left and the limit from the right. So everybody look up here at my screen so I can highlight the limit from the left and the limit from the right. So as we approach 7 from the left, here's me highlighting it. Negative 3.41, negative 1.94, negative 1.9252. That's from the left. What about from the right? As we approach from the right, 0.46, negative 1.91, negative 1.9248. So far, so good? Now, are the left-hand limits and right-hand limits going toward the same number? Yes. And approximately what number is that? Yeah, negative 1.9252 and negative 1.9248 are pretty much straddling around negative 1.25, right? Yeah. Cool. So this first one says, as we approach x equals 7, the value of g of x definitely approaches this. Isn't that pretty similar to this one?
Yeah.
The value negative 1.925 is a reasonable estimate? Cool. Tables are not perfect. Tables will never tell us what the limit is definitely approaching. The only thing that would tell us what the limit is definitely approaching would be the actual function, all right? A table is not enough information. So I would say this so far is a better answer than A at least, that negative 1.25 is a reasonable estimate, not that it's definitely the limit. Some people said B, the limit doesn't exist because the function is undefined. Remember, I do not care what's happening at 7. If there's an open circle, that is okay, as long as around it, it's going toward a value. And then a lot of people chose 3. There appears to be an asymptote at x equals 7. Remember that an asymptote at x equals 7 would be a vertical asymptote, right? A vertical asymptote means it would follow it up, the asymptote to infinity or down the asymptote to negative infinity. And these numbers are not really large, are they? These are not even close to infinity. If this number was like 1,759,000 then maybe there was an asymptote. But the fact that they're nowhere near being that large means that there's probably not an asymptote at x equals 7. So I would say D is the most logical choice here, that this is a reasonable estimate of the limit as we approach 7. Okay? Questions on example 3 before we look at number 4? Okay, let's look at number 4. So we're going to stray away from tables for a little bit and go back to graphs, but we're going to look at these different properties with graphs. So do you guys see down here what it's asking us? The limit of g of x minus h of x is equal, as we approach 0. They want to know what that limit would be. So with this one, here's how you do it. I'll do the first one for you, and then after I do the first one for you, I'm pretty sure you guys could probably figure out the other ones on your own. But if you need help, I'm always here to help. So here's how we're going to do this. We are going to evaluate the limit of g of x as x approaches 0, and then we're going to evaluate the limit of h of x as x approaches 0, and then we're going to subtract our answers. And that's it. So write this down on your paper. The limit of g of x as x approaches 0 equals the limit of h of x as x approaches 0 equals when we look at g of x, that's this first function up here on the board. When we look at this graph of g of x and I get close to 0, I get close to x equals 0 from the left and I get close to x equals 0 from the right, what is it going toward? Good. The output would be -1. So the limit of g of x as x approaches 0 is -1. Write that down. -1. What about the limit as h of x approaches 0? So as we look at h of x and we go from the left and we go from the right, what's that going towards? 0. In conclusion, the limit of g of x minus h of x as x approaches 0 is... What would you get if you subtracted those two limits? -1 minus 0? -1. Beautiful. So the answer is -1. When you're done with that one, flip it over to number 5, example number 5. On this one, by the way, do you guys remember doing these types of things in IM3? Like where you multiply a function by -2 and it was not a normal function, it was a function like this? Essentially, all it means is to take all the y values and multiply them by -2. So this point, instead of being at -3, 5, would have been at -3, -10. If I multiply 5, the y value, by -2, it would come all the way down to -10. This one, instead of being at 2, 1, would have been at 2, -2. So all it does is take the y values and multiply them by -2. So this one, in this case, says, what is the limit of -2g of x as x approaches 0? So essentially, what is the limit now, by the way, of g of x? 3. The limit from the left is 3. The limit from the right is 3. Essentially, if we had multiplied that by a -2, where would the limit be now? -6. Good. So here's the work I want you to show. I want you to write the limit of g of x as x approaches 0 equals 3. So for the limit that they're asking us in this problem, we're just going to do -2 times the limit we got for g of x, which would be -6. And if you want to write a little arrow for yourself, like, hey, where did that 3 come from? You can write a little arrow that that's where that came from. That's the limit of g of x as we approach 0. All right, I want you guys to try and do the next 2 on your own. Try examples 6 and 7 on your own. I'll give you 2 minutes if you need 2 minutes. If you're watching the video, you can pause it again. What did you guys get for the limit of g of x as we approach -2 over here? 5. Good. It's okay that there's a hole there. It does not matter there's a hole. It's okay the function equals 1. I don't care about that. I care about what the limit is going towards, which is 5. What about for the other function, for h of x, the limit as we approach negative 2 was? 1. Perfect. So hopefully you guys filled in the blanks that if I wanted to divide them, g of x divided by h of x would have been 5 divided by 1, which is 5. Beautiful. Questions about number 6? Let's look at number 7. Number 7 says, what's the limit of f of x times h of x as we approach 0? What did you guys get for the limit as we approach f of x towards 0? Good. The limit of f of x as x approaches 0 is 1. What about the limit of h of x as x approaches 0? Oh, good job. Why not? There's a jump. The left and right hand limits are not equal. From the left it's 3, from the right it's 0. Therefore it does not exist. So what does that mean about our limit of when you multiply them? It does not exist. Yes, the limit does not exist if either one of them does not exist. And last but not least, the last thing we're going to look at today is compositions, limits of compositions. So there's two problems. I don't know if you guys can see it. There's one down here at the bottom of the page, and then there's another one up here at the top of the page. So I'm going to do with you guys this one. I'm going to do this one with you. So for this one, it says the limit as x approaches 3 of g of f of x. Do you remember how compositions work in terms of like what you're evaluating first? What do you do first? The inside. So I'm going to evaluate the limit as we approach 3 for f of x. I'll write that here. So I'm going to say the limit of f of x, which is the inside function, as x approaches 3. And what would you guys say the limit is? Negative 1?
Yes.
Perfect. So here's 3, and the limit's negative 1. I take that value, and now I'm going to evaluate the function g, which is the outside function. So we did the inside first. Now that I know my limit for f of x, I'm going to take that value and evaluate g at that limit. So I'm evaluating this. I want to know the limit now as x approaches negative 1 for the function g of x. And again, if you're trying to follow along with where these numbers are coming from, the limit answer for the inside is my new value that I'm approaching for the outside function. So whatever I got for the inside is my approaching value. So one more time. My limit is what I'm going towards 3, and I evaluate the inside first. So my limit for the inside function f of x at 3 was negative 1. And now, because this is a composition, I want to evaluate the outside function, which is g, at the new limit, which was my answer for the inside function. So my new limit is negative 1. And what do we see on g of x at negative 1? What's happening? There's a jump. Therefore, the limit does not exist. So the answer for this one is d and e, does not exist, because there's a jump. Try the other one that's up there in the top right-hand corner, the limit of f of h of x. Oh, let's do, sorry. Can you guys change that to a g, f of g of x? Right here. Sorry, I didn't realize on your papers that that's a different one. Up here changes to f of g of x. I'll highlight it. F of g of x. When you're done, you can check your answer up here on the board. I've circled it in purple. And then the bell's about to ring in just a second. So your homework is page 67, 55 through 60. If you have questions about this problem, please let me know.